All right, this is part one of the reviews for rational functions. In this part, I'll be talking about the algebra problems, and then in the second video, I'll be addressing any of the graphing stuff that goes on here. All right, short and simple. What I should say here is that the algebra problems, you need to be able to factor. If you can factor, you're going to be in really good shape. If you can't factor, that's going to cause some trouble for you. Okay, as I go through the problems, what I've already done off to the side here is I've factored pretty much everything, just so you can see really what you have to do after those points. And again, if you don't know how to do the factoring, that's a whole different issue that I'm not going to really cover in the video. Okay, the first question does look different than the rest of them because we don't have any adding or subtracting that's going on within the actual expression. So this really just sort of comes down to, do you know how to reduce numbers, and then also the product and the quotient rules for exponents. All right, what I've done so far in this part that I've written, I just really copied that down. But when I copied the second one, because it's a division problem, you need to flip that fraction. You're going to flip it and then change this into a multiplication problem, and everything just works out a lot better that way. Technically, you are allowed to divide straight across in these things, but you're going to find out in the other problems that things might not work out really well that way. So keep, change, flip is the general rule that we tend to go with. Okay, once I do have this flipped over, what you want to do is think of it as three parts, at least in this problem. You have the number portion of it, and then you have also got the letters, like x's are separate from y's. So you have the numbers, you have the x's, and you have the y's. Okay, with looking just at the numbers here, numbers are going to be chosen for reasons. They're going to have certain things in common. Like the 5 doesn't divide into 54, but once you do the flip and you get the 18 actually does divide into 54. In fact, it completely divides into it, and it just gives you back a 3. So the 18 is now removed from the problem, and as far as your numbers, all you have left are the 3 and the 5. So that's going to give you a 15, which is going to be the top side of your problem. Since, of course, those are in the numerator, then it'll be on the numerator there. Okay, the x's, you could do product rule first. Basically, you add your exponents. So if you have x to the 4th and you add x to the 1st power, that's going to give you x to the 5th power. And so you add x to the 5th. The bottom, all you've got is that x squared. So then you just take a difference of them, which is going to be 3. And if you're top heavy on the x's, then just keep them like up in the top. We then do the same thing for the y's. You have y to the 3rd, y 2nd, which is going to give you y to the 5th. The bottom, if you add these together, you are also going to get y to the 5th. They completely cancel each other, so there's no reason to write a y. Don't do anything creative like adding a y to the 0 power or anything like that. Just, which would actually be correct, but don't do it. This is your answer, and you'll notice that we don't have a denominator, so you don't really need to put the 1 as a final answer. You can just write this as 15x cubed. Now, important point here though, if everything in the top cancels, make sure that you do have a 1 over those things. You can't just eliminate the 1 there. All right, second question. You've got multiplication, which is going to require you to do some factoring at the beginning. I've already gone ahead and done the factoring. What multiplies to give you negative 36 and adds to give you 5 will be 9 and negative 4. This is a difference of squares, so you get minus 7 plus 7. This is going to factor into negative 7 and a negative 4. Their product does give you positive 28, but then the negatives together give you negative 11. Notice that there's nothing under that, so you should put a 1, which could also be very important if you get a division problem, because that would then move all this to the bottom. But being that it's multiplication, this is our setup that we want from the beginning. And you can factor like, well, if it was keep, change, flip, you can just factor at the same time if you want. But anyway, we get to this point here, and then all you really do is you look for common factors. That x minus 7 is going to cancel with this one. This, oh, those don't cancel. I was looking at them, the x minus 4 and that x minus 4. They don't cancel because they're on the same side. So we're going to be tempted to remove them, but you don't actually get to cancel them. And it looks like this is all that we're going to get to cancel. So you did get something. If you don't get anything, I'd be skeptical with that, but that's all we got. Okay, so when you put this together, if you want to, you can write that as squared, or you can just write them individually. And you get your x plus 7 on the bottom. And do not multiply these together. Yes, at the very beginning, all this is in standard form, and we factored it to cancel, but don't put it back into standard form. It's a waste of time. That what it ultimately does is it creates more work where you could make mistakes, and I'll be honest, this is great. Just keep the answer like that, and then long term you'll figure out in other courses like calculus that keeping it in that form is actually better for you. Okay, next we have a division problem. Yeah, division. So this is gonna involve a keep change flip. It's gonna be in there. The only thing that's really different with this question aside from the division is the type of factoring that shows up in here, because you do have that a value of 3. So this part right there is going to take you a little bit longer. You're going to have to do some factoring by parts, which I went ahead and just worked out here so I can just talk about it. The approach that I take at factoring by parts, and the way that I teach this, I grab the a value and the c value and I multiply them. I usually show that on top there. Okay, and it changes the game a little bit. I'm looking now for numbers that multiply to give me 12, their product, not just the 4. Okay, numbers that multiply to give me 12 and then add up to give me that middle term. That's going to be a 12 and a 1. And both of them being positive to add up to positive 13. So I break up the 13 into a 12 and 1, because remember they add to give you that. So I break that up, I drop down the other terms, and then I do what is actually the factoring by parts portion of this. You do a GCF of the first two terms, which is going to allow you, in this case, to divide out a 3x, leaving behind an x plus 4. Now, since I got it all written, I'm going to cover up a little bit for a moment here. You divide that out and you get this. The expectation when you're factoring by parts is that the other parentheses is going to be the same as that one. That's the only way that it works. Okay, so I can already look at this and say, I've got that x plus 4. So what do I factor out to keep that? I factor out a 1. So then I got the plus 1 out front. I've got this. All right, the next part I don't really talk much about as far as how the factoring portion works here, because once you get here, you got the numbers that you really need. So we'll just take them and roll with it. The x plus 4, which showed up twice, gets to count as one of your factors. Then the outside portions of it are going to pull together and become your other one. Okay, so then these are multiply back together and give you this. But of course, I'm not going to put them back together. You have the difference of squares, which I'd factored. There's a keep change flip, so the x plus 2 is moved to the top. The 4x plus 16 is a GCF problem. You're going to divide out of 4, which is going to give you 4 times x plus 4. At this point, you look for common factors. And if you don't have anything in the top matching something in the bottom, then maybe you forgot to flip this guy over. All right, so these are going to cancel. These are going to cancel. And if I didn't flip this over, if I didn't flip it, these would have been on the same side here and they wouldn't cancel. These would have been on the same side and not cancel. So that would be a sign like that you're missing something in the problems, because you never cancel side by side. It's always top and bottom. Okay, so take everything that we got. We'll just build a fraction out of it. Make sure everything's there, and that's it. Don't distribute in. I mean, you can if you want, but no real reason to, so I just let it be. All right, next, in my opinion, the harder two problems that we get into, addition and subtraction. All right. Okay, so here's our addition problem. We've got, the main thing about this is common denominator. You don't get to just factor and then start canceling things out. You have to factor the denominators to figure out what makes them unique. You have to balance those things, and then it usually goes pretty fast after that point. Okay, it's just a bit messy looking when you go through it. Okay, so I've factored these again just to save a bit of time. And what you're going to notice is that they do have one thing in common. Don't expect these to be completely different than each other on the test, because then that becomes a really long problem. And it's not a good idea for a test just to make a problem long for the sake of being long. Okay, so they do have something in common, which is the x minus 4. But they also have something that's unique. This has an x plus 3 that doesn't exist over there. So if you multiply the top and the bottom by x plus 3, then it gets that piece. And that portion of it is now balanced, and it's fair. Okay, the 12 is unique to the right side. So if I just multiply the top and the bottom by 12, that balances out that part. And this, right, is the same thing as that, which is going to be your common denominator. And don't multiply any of it. Just leave it alone. Okay? Now for the top, you do need to multiply things because we're going to look at how they group and possibly reduce. Okay, so you're going to have the 12 times the x. It's 12x. You're going to have the 5 that distributes in. So we're going to get a positive 5x plus 15. These are going to group together, which is going to give you 17x. Then there's your plus 15. And the big question at the end of this is just whether or not that factors and creates a factor that matches the bottom. Sometimes these factor and they don't match anything. but you check to see if it does factor and if it can be reduced. And about 50% of the time, to be honest here, about 50% of the time they're not going to, because they're hard questions to actually create where that occurs. All right, this one doesn't factor. There's nothing in common between the 17 and the 15. We just box it up and that's that. All right, subtraction. We're moving right through all the operations, right? We did multiply, divide, we did adding, so here's subtraction. Okay, and then if you didn't pick up on this when we covered it in the notes, the main thing about the fraction, or the subtraction problem, sorry, is distribution. You got to distribute. If you don't distribute that negative, you're going to be off by a number and it ultimately ruins the problem. Okay, so I've factored everything for us here. We look at what they have that's common. They both have an x plus 2, but this one has 2 of them. That one has an x minus 2. So you have to share the things that they lack. Over here, we need another x plus 2. And on this side, and I leave a lot of room there, but we need an x minus 2. Okay, and again for the denominator, don't multiply anything, right? Just list them. I'll do all my positives first. And you could write that as a squared if you want, but it doesn't really make a difference. Okay, for the top, you get a FOIL. Multiply all of it out. You're going to get an x squared. You can get a negative x. You can get a negative 2. Okay, then over here, let's watch this real carefully. This multiplies to give you a 6x plus 12. But that minus is going to have to distribute. You're going to get the first one. You're going to get the negative 6x. That you're going to see. It's going to be that second one. Does that negative distribute all the way over here and show up as a minus 12? That's the part that you're getting graded on in this question. Everything else about this is an addition problem. Everything about the same. Okay, like division, it's keep, change, flip. That's the difference from multiplying. This distribution is what changes our problem here. So you want to make sure you get that part right. Okay, so if we group things, we're going to have an x squared. Let's see, these become a negative 7x, and these become negative 14. Okay, so we're thinking, is there anything that multiplies to give us negative 14, which is going to add up to give us negative 7? And our factors for 14 are a 2 and a 7, or a 1 and a 14. So those aren't, even with being opposites, they're not going to give you that negative 7. So like in the last one, you don't get anything reducing. But you want to check, because about 50% of the time, something's going to reduce. All right, complex. Here we are, the complex fraction. Look, it just looks messier at the beginning. But ultimately, this is what it is. That bar right in the middle there is this division. So what you have is a numerator where there's some subtraction going on. You have a denominator with adding, and if you just do those two parts on their own, then you get to a keep, change, flip problem, and it's all fine. The trick is just being able to interpret what it is that we're looking at, and that's all it is. That's what it is. Okay, the 4, I am going to place it over 1 that you can see, and the 3 I'm also going to place over here. Okay, for this particular question, yes, you need a common denominator. But in the simplicity of how these fractions are written, there's a different method that I use, and I want to demonstrate that here. I call it the happy cyclops. It's a little face over here. So I'm going to apply that to this strategy here. And you can do this anytime you're adding and subtracting fractions. Okay, what I'm going to begin with is almost like cross products. I'm going to multiply the 2 times the 1, which will give me a 2. I'm going to use my operation, so that's a minus. Then I'm going to do the other diagonal product, which is going to give me 4x. That will be the numerator to this subtraction. The denominator is going to be the product of the x and the 1, which give you an x. And you can see that little face that shows up there. All right, we got division. We'll flip it a little while later from here. Now I'm going to multiply 3 by x. I'm going to add 1 times 2, and then I'm going to place that over 1 times x, which is x. So next we do some key, change, flip. And just slow pace the stuff here. You know, you can factor out a 2, but we'll see if we need to in a moment. Okay. When we flip that over, the x's, they're going to cancel. All right, so we've got 2 minus 4x is over 3x plus 2. yes, you can divide out of 2, and that'll give you a 1 minus 2x. But that doesn't create a factor that's the same factor that we got on the bottom. That's all packaged out into the 3x plus 2. So here it just finishes. Okay, but if there was something that you could factor out and then divide from both of them, then you would look at it in that spot. All right, last for this video, which has actually gone a lot longer than I thought, but it's fine. Inverse variations. The reason that we even talk about these in this unit is because an inverse variation is a rational function. Okay, the y is equal to k divided by x. It's a very simple equation. You just have this thing called the constant of variation, but when it's divided by x, it gives you the y value. Okay, and anytime you have an x as a denominator, then that's going to be our rational function. So that's how it ties in, but there's no adding or subtracting or extra stuff attached to it. So when you come to this problem, and it says that y varies inversely to x, start with this template. We're then going to give you two values that you can place into the equation. Okay, so you can have k over 2.5 for the x. That's going to be equal to 8 for your y. And then you're going to be asked, what would be the y value if x were some given number? And the way that you go about this is you find the k from the first setup, because it's the only variable in there. So if I multiply 2.5 by 8, that's going to give me 20. So I get 20 is equal to k. And then I can take that k and I can put it into another equation. Look, the x is what's given to me, so I'll put it on the bottom. There's your y. Okay, well, what's 20 divided by 4? It's 5. And that's it. So it's a super easy question. Just start with your template, solve for the k, so on. You might also notice that in the problem here that the k value is really just the product of your x and y. So you could start at that point too. If you know it's inversely varied, you can just multiply those numbers and then that's your k value and just set up your problem from there. All right, that is the end of the first video, and we'll tackle the graphing in the next one.